Hello, I'm Camilla Gilmore and I'm a professor in the Centre for Mathematical Cognition at Loughborough University, and this video is going to be looking at the mathematical learning difficulties that sometimes follow preterm birth. So in the video I'll start off by explaining what I mean by preterm birth and why I think educational professionals need to know about this. I'll describe some of the long-term effects on cognitive development and the impact on learning and education. And then I'll talk about a couple of research studies that we've run that look at the nature of the difficulties that are associated with preterm birth, specifically around mathematics. And finally, I'll finish up by considering how we can support children born preterm in the classroom, and I'll point you to some additional resources to find out more. So first of all, prematurity or preterm birth is the single biggest cause of newborn deaths. But fortunately, thanks to improvements in medical care, severe physical disabilities and illnesses are increasingly rare. However, it is the case that we still see difficulties with cognitive skills, and these are much more common than physical disabilities, and this can have a real impact on a child's education. So globally, there's about 15 million babies born preterm each year, and in the UK, this is around 8% of all babies. And it's worth noting that preterm birth rates are rising. So the numbers of children born preterm and therefore entering the education system is only going to increase in the coming years. And as a result of that, almost all teachers will be responsible for supporting children who are born preterm. So it's estimated that about 2 children in an average UK primary school class might be born preterm. So first of all, thinking about what specifically do we mean by preterm birth? Well, a typical pregnancy is around 40 weeks and it's considered to be term if a baby's born after 37 weeks. So anything before that is considered to be a preterm birth. And within this, we can see some divisions between babies who were born less than 32 weeks is considered very preterm. Beyond that, there's moderate or late preterm, and extremely preterm birth, the earliest born are babies that are born before 28 weeks of gestation. And studies have shown that the risk of difficulties and also the severities of the difficulties increase the more preterm that a child is born. However, given this, it's also the case that effects can be seen after birth just a few weeks early. And it's really important to stress at this point that what we're talking about is the risk of difficulties. So preterm birth is just a risk factor for long-term difficulties. It's not a diagnosis. So not all preterm born children will have cognitive or educational difficulties, but the risk is higher for preterm born children than for term born children, and the risk is higher the earlier that a baby is born. So there's been quite a body of research now into looking at the consequences of preterm birth, and there's some quite consistent findings from studies across the world that have shown that preterm children may have a particular pattern of difficulties across different areas of development. So I'll just describe some of these typical findings first. So the areas of difficulty can include neurosensory difficulties, as well as impacts on cognition and behaviour and emotions. So in terms of neurosensory, well, thankfully rates of cerebral palsy and serious vision and hearing impairments are quite low, but there are higher rates of difficulties with fine motor skills or visuospatial skills, so hand-eye coordination, things like that. In terms of cognitive skills, well, there's a risk of lower IQ in general, as well as specific difficulties with working memory, processing speed, executive function, and inattention or attention focusing difficulties. And in terms of behaviour and emotions, We also see research suggests there's a pattern of some attention problems, as well as difficulties with peer relationships and anxiety or emotional disorders. And one thing that's important to note is that there's no increased risk for conduct problems. And in fact, preterm children's difficulties are more likely to be internalising difficulties rather than externalising difficulties. So they may be withdrawn or have difficulty focusing, but show that through inattention rather than hyperactivity, for example. So these are the typical areas where researchers suggested there may be difficulties, but the different impacts don't always go all together. So a preterm child might have difficulties in one area, or they might have difficulties in several areas. In this video, I'm going to focus on cognitive difficulties and the impact of this on education. But it's really important to note that many preterm children's anxieties will also have a major impact on their experiences and achievement in school. So it's just as important to take this into account as well as the cognitive difficulties. So, given that preterm children are at risk for cognitive difficulties, it's not surprising that this can have an impact on their school attainment. So this graph shows data from a large study of preterm children in Scotland. So the graph shows the percent of children with special educational needs for groups of children who were born at different weeks of gestation, so from 24 to 40 weeks. And we can see that the rates of special educational needs are highest for the children who were born before 26 weeks of gestation. So here we've got up to half or over half of the children had a statement of special educational needs. But it's important to remember that only a very small proportion of babies who are born preterm are born at these very early gestations. So there's actually many more babies who are born, for example, between 34 and 36 weeks of gestation. And so although the chance of having SEN is lower, this is the group that you're most likely to encounter in the classroom because there's many more babies born at these weeks of gestation. And they are still at higher risk of having special educational needs than children who are born at term. But it's also the relationship between the level of a child's difficulties and their gestation is not exact. So many preterm children who are born moderately or late preterm, they may have difficulties that don't reach the level of diagnosed special educational needs, but they may still struggle in comparison to their term-born peers. So they may have moderate difficulties over a range of different areas. So that's how the level of difficulties might relate to weeks of gestation. But what sort of areas of impact might we see in education? So we know that as a group, children born preterm have lower attainment across all subjects, but studies have shown that they're most likely to have difficulties with mathematics. So this is the area of the greatest risk. And this can be seen right from the earliest stages of education. So this graph is from a study that was looking at 5-year-old children's achievement across the different EYFS subject areas. So this is from a few years ago now, where we had these different areas of learning that were assessed. And the graph shows for the overall attainment and also for each of the areas of learning, the percent of children who were considered to have reached a good level of achievement. So this is given both for the overall and the different areas of the early years curriculum. So in this graph, the blue bars are for the group of children who were born very preterm, and the orange bars are for the children born at term. So we can see there's a difference between the blue bars and the orange bars across all of the different curriculum areas. So the very preterm children were less likely to reach this good level of achievement across all of the areas of the curriculum. But we can see that the difference between the bars here is greatest for mathematics. And if we look at this specifically, we can see that for maths, there was 70% of the term-born children had reached a good level of achievement, but only 46% of the very preterm children. So there's quite a substantial difference here when we're looking at their very early mathematical development. So this was looking at children who were right at the start of schooling in the early years, but this particular difficulty with mathematics continues throughout schooling and in fact into adulthood. So there's fewer studies with older children, but those that we have got show that at the end of Key Stage 2, we still see that maths was the greatest area of difficulty for preterm born children. And this is the case both when either direct measures of achievement are used or teacher assessments. There's been less research with secondary school children, but the studies that do exist continue to indicate that maths is a particular area of difficulty. And in fact, even in adulthood, studies have shown that maths difficulties can explain impacts on quality of life that are seen for preterm born adults. And this is likely to be because math skills we know are associated with future employment status and quality of life. So I'm going to think a little bit more now into maths difficulties and why they may come about. So although we've got some evidence so far, there are still lots of remaining questions, and this is why we started doing some research into this area. Specifically, we want to know about what's the risk of difficulties with maths for preterm born children as they progress through primary school and into secondary school? And then in particular, what areas of mathematics are affected and what causes these difficulties? Because we need to know this in order to think about what kinds of support these children might need. So I'm going to talk about a couple of studies that we've been involved with at Loughborough. And these were funded by the charity Action Medical Research. And these have looked at mathematical difficulties in preterm born children. And there's been two studies, one looking at children when they were in primary school, so they were aged between 8 and 10 years old, and the second looking at children in secondary school when they were aged between 12 and 14 years. And in both studies, we looked at measuring overall mathematics achievement, but also some specific mathematical skills and also cognitive skills in a group of very preterm children. So these are children born before 32 weeks of gestation. And we also compared this with performance of their peers and their classmates. So the way we did this, we recruited a group of very preterm born children. And then for each child, we tried to recruit a classmate. So the very preterm children came from a wide range of different schools. They had all the preterm children had originally been born in either in a hospital in London or a hospital in Leicester, but they were now at school in quite a wide range of areas. And so for each preterm child, we tried to recruit a classmate who was born at term, but who would have had a similar educational experience as them, who were in the same school. And we had 115 very preterm children, and we didn't quite manage to get a term-born peer for all of them, but we had 77 term-born peers. And we found that the groups were well matched for sex, age, for mother's age at birth and education, and parent occupation, but there was a small difference in socioeconomic status. So we took account of this in all of the analyses we did. And so the children spent a day with our researchers who came in to see them at school, and they completed measures of standardised mathematics achievement, overall achievement measure, which was the WIAT, and also a wide range of measures of very specific mathematical skills, as well as cognitive skills. So the specific math skills included things like counting, their children's use of arithmetic strategies to solve arithmetic problems, their understanding of arithmetic concepts, number fact knowledge, and also measures of basic numerical representations. So we wanted to see if the preterm children had some sort of basic difficulty in dealing with numerical information and struggled to represent and process numerical information. And we also measured cognitive skills, including working memory, visuospatial skills, processing speed, inhibition. So first of all, I'll look at the results for this first study for when the children were aged between 8 and 10 years old. And this graph shows their scores on the overall measure of standardised mathematics achievement. So this is the Wyatt measure. And the graph shows the mean score for the group who were term born and the preterm born, and also shows the standard deviation. So you can see there's quite a range of scores for both groups, but we can see that there's a group difference here, and the effect size is about half a standard deviation. If we look at the more specific measures, so the group differences in terms of the cognitive skills, the group differences were in working memory and also visuospatial skills, so how children can use visual and information to process the sort of spatial positioning of items. And then if we look at the specific mathematics skills, we found group differences in children's use of arithmetic strategies. So this task asked children to solve a series of arithmetic items, so addition and subtraction, for example, and we asked the children to describe how they'd solved the problems after they'd done them. And we looked at whether children were doing things like counting on their fingers, counting mentally, using decomposition strategies, or retrieving the answer. And we found that in particular there was a difference in these strategies, that the very preterm children were tending to use less advanced strategies. So they were much more likely to be counting on their fingers, for example, rather than using mental decomposition. And we also found differences just in basic counting skills, so how accurately children could count up and count back out loud when they're not counting items, when they're just counting knowledge of the count sequence. But most importantly, and the most interesting finding, was that when we took account of the differences in children's cognitive skills, so when we statistically accounted for the difference in working memory and visuospatial skills, we found that these differences in arithmetic strategies and counting skills disappeared, and there only remained a difference in overall mathematic achievement. And that difference was the effect size was reduced by about half. So what this means is that it's children's difficulties with working memory and visuospatial skills, the preterm children's, that's explaining quite a lot of the differences in their mathematical skills. So specifically these specific measures were completely accounted for by the cognitive skills difficulties, and quite a lot of the difference in overall achievement was also explained by differences in cognitive skills. So to summarise the first PRISM study, we found that very preterm children don't have a fundamental difficulty in dealing with numerical information. So we found no difference between the groups in terms of these basic tasks looking at numerical representations. And instead, it seems likely that the children's difficulties in mathematics come from their general cognitive skill difficulties. So this was looking at children when they were sort of towards the end of primary school, so aged between 8 and 10 years old. So this raises the question of what happens when children progress through school and move into secondary school. So, we know that the mathematics gets a lot more complicated in secondary school, as well as the whole negotiating and coping in school generally. So it might be that this causes more difficulties for children, and the preterm children might fall further behind. On the other hand, it's often thought that the effects related to preterm birth are more focused on children when they're younger. So it could be that as children grow up, they catch up with their peers, and the difference between the preterm and the term-born children might reduce. And also there's a question about where might their areas of difficulty particularly be. So as we go into secondary, there are new areas of mathematics that they're introduced to, and so this might mean that there are new or different areas of difficulty. So because of that, we were able to get some funding to follow up this study a number of years later, and to see these children again when they're in secondary school. So we were able to recruit as many as we could of the original sample, and we also recruited some new participants who hadn't been involved in the first study, who'd been born originally in hospitals in Nottingham. And so our total sample for the follow-up PRISM study, we had 127 very preterm children and 95 term-born children. And a large majority of the very preterm children and about half of the term-born children had taken part in the original study before. So we've got a new sample of children who are all in secondary school, and some of them had been also involved during primary school. So these children were seen when they aged between 12 and 14 years old. So again, we looked at whether any of these other factors might differ between the groups, and this time we found that there were no differences between the groups in any of the other factors, so like sex, age, mother's age and education, parent occupation, and also socioeconomic status was not different between the groups in this study. So once again, we gave standardised measures of mathematics, so the WIAT as an overall maths achievement measure, and also measures of specific mathematics skills and cognitive skills. So there was some new specific mathematical skills that we looked at given children's older age. So we looked more at written arithmetic, we looked at transcoding, so reading and writing multi-digit numbers. We also looked at algebra and geometry, as well as all the areas that we'd looked at before. So the results from this age group, so first looking at the overall mathematics achievement measure, so our standardised WIAT measure, and it's a very similar picture to the earlier time point. So again, we're seeing that the children in the term, who were born at term, are scoring higher on average than the children who were born preterm. But again, there's quite a wide variation, so the standard deviation's quite broad, and the effect size is similar than it was in the earlier time point. So then we're looking at the cognitive skills, and it's a similar kind of pattern. So for the cognitive skills, again, we saw that working memory and visuospatial skills were the areas where there was a difference between the groups. So the very preterm children are on average doing less well with working memory and visuospatial skills. And then looking at the specific mathematics skills, we saw there was a large number of tests where the preterm group were performing less well than the term-born group. So this included both reading and writing multi-digit numbers, again counting skills, also number fact knowledge, written arithmetic, so using the algorithms for written arithmetic, and as well as understanding of arithmetic concepts and algebra. And once again, we looked at, once we statistically take account of children's difficulties with working memory and visuospatial skills, how many of the differences in the math skills remain. And it was a very similar pattern, so most of these specific areas of difficulties were no longer evident once we took account of children's cognitive skills, and the only remaining areas of difficulty were the overall maths achievement measure, and also a task that asked children to identify concepts through identifying related arithmetic problems. And that's a task that has quite a high cognitive challenge to it anyway, so that might be why this area is one that remains an area of difficulty. But the overall picture was very similar before, that most of the differences and most of the difficulties with mathematics skills were accounted for by the very preterm children's difficulties with cognitive skills. So those results were considering the whole group of children that we had in secondary school, but as I mentioned earlier, some of those children had taken part in the earlier study and some didn't. So what does the pattern look like, the extent of mathematical difficulties, if we look just at children who took part in both studies, where we can really quantify, are the differences getting bigger or are they getting smaller? So these graphs are looking just at the children who took part in both studies, and they show the difference in the overall maths achievement measure for children when they were in primary school and in secondary school. And we can see that the differences between the mean scores for the term and the preterm group are very stable and consistent from primary to secondary school. So we're not seeing that these children, the preterm children, have caught up. We're also not seeing that they've fallen further behind. So on the one hand, that's hopeful that if actually we can support preterm children right at the start of education, then perhaps we can prevent these differences developing. And we really need to help them in the early stages, because the differences don't seem to be getting bigger, but they are remaining. But it is also worth noting that there was a higher level of extra educational support in the preterm group. So this difference has not reduced, despite the fact that there were higher rates of extra support for the preterm children. So they're already getting extra support, and this isn't helping them to catch up. It's just meaning that they don't fall further behind. So I think there's still quite a lot to be done in thinking about how we can support preterm children. So overall, to summarise across those two studies, they've shown that very preterm children continue to be at risk of mathematical difficulties into secondary school. But importantly, across both time points, when we took account of children's working memory and visuospatial difficulties, there were no longer differences in most of the specific math skills. And so this suggests that preterm children's difficulties with maths arise from their difficulties with these general cognitive skills. And so although the greatest impact of premature birth might be on mathematics, this isn't because of it's a specific mathematics difficulty, so it's not a specific difficulty with processing numerical information. Rather, it's because maths draws heavily on the cognitive skills that might be affected. So we know that maths draws heavily on working memory and visuospatial skills anyway. So if very preterm children have difficulties in this area, it's not surprising that the biggest impact at school is on mathematics. So what does this mean for supporting preterm children? So if we know that their difficulties are likely to stem from differences in cognitive skills, then how can we support them? And so there's a number of things that we can think about that might help children who have working memory or visuospatial difficulties. And it's worth noting that these aren't specific to preterm born children, so any child with working memory or visuospatial difficulties might be supported in these ways. So I'm going to just give you a few little examples now, and then tell you about a resource that can give a lot more examples, a lot more help. So first of all, if we think about working memory, so children who have poor working memory are going to have difficulties holding and processing information in mind. So we might want to do things like giving short single-step instructions, and if there is a need to give a sequence of instructions, making sure that children with working memory difficulties have got a way to check back what they're meant to be doing. We might want to use memory aids to reduce the working memory demands, particularly when we might be introducing new ideas or focusing on one thing in particular. So this could include spelling or word cards, counters, number lines, number squares, multiplication grids, so on. And also it's really important to work with the child to develop their own memory strategies, so things like chunking information and helping them to know when verbal rehearsal might help or when it might help to write something down. and help them to recognise when they might need to think about additional memory aids. And it's worth noting as well that like number fact learning difficulties are very common when children have working memory difficulties. So very preterm children or preterm children might need extra help and support around number fact learning. So then moving on to visuospatial skills. So if a child has difficulty with visuospatial skills, then they might have problems coordinating visual information with their movement. So hand-eye coordination might be difficult, but they also might find it difficult to take in visuospatial information from resources and so on. So they might need extra time for activities. So even something like copying information from a board is surprisingly complex if you have visuospatial difficulties. So something like that that might seem quite simple can take more time. And they might need differentiated resources in some places where, for example, giving them more space to work. So on worksheets, making sure they're not too cluttered, there's not too much information there, or that they've got more space to work with, that the number squares or number lines they're working with need to be big enough that they can differentiate the information and take in what they need. Things like using multi-digit numbers and column arithmetic can be really challenging, and they might need some sort of extra large squared paper or more structure to where they're working to help them to get this right. And it's important to think about when we might want to use 3D or 2D resources, particularly around manipulatives, or when we're exploring topics such as area or volume. It's quite challenging to infer 3D information from 2D resources, so some 3D resources might be particularly helpful here. So that's thinking about particularly working memory and visuospatial skills. But if we want to think more broadly about supporting preterm children in school and in the classroom, how can we help them? So we know that cognitive skills is this underlying cause of many of their educational difficulties. So it's quite tempting to think, well, should we be focusing on training cognitive skills? But we know that unfortunately that just doesn't seem to be successful, that cognitive skills training doesn't seem to transfer well to educational outcomes. There have been some attempts to try with very early interventions for preterm born children, but even where there have been impacts of the intervention, these results fade out very quickly. And I think it's also important to know that if you're working in education, that very preterm children will only routinely be followed up clinically for up to 2 years. So at the 2-year check, if they seem to be developing on track, then they won't necessarily have any more checks until it's the point when they come to school. And so any difficulties with cognitive skills are that may begin to emerge after the age of 2, may not be picked up or noticed until children get to school. So we think it's really important to equip teachers with knowledge about prematurity and an idea about some of the areas of difficulties and how to support children who may have particular difficulties. And we know this is an area that teachers don't get very much information about. So we did a survey a few years ago with teachers and also with educational psychologists, and most of them repeated receiving no information about preterm birth, and consequently they'd had little confidence in how to support preterm born children in the classroom. So in response to this, we've developed a free resource for educational professionals, well, for anyone who wants it, parents, educational professionals, health professionals. It's at the website pretermbirth.info, and it's designed to provide information about a number of different areas related to preterm birth and children's outcomes and development and their schooling. So there's sections about what is preterm birth, their typical educational outcomes, cognitive and motor development, behavioural, social and emotional outcomes, and then also providing a number of strategies and information about how to support preterm children, both in general in school and also specifically with mathematics. So the resource, we worked with teachers and educational psychologists, with parents of preterm born children, and also preterm born young adults who were able to talk about their own experiences in school and what they wished their teachers had known about preterm birth. So it provides this information about the long-term consequences and the strategies. And it includes case studies and children's own experiences. So the resource is designed around 5 little short sections that you can dip in and out of. So each of the sections are only about 10 minutes, 10 to 15 minutes it would take to work through it, and you can dip in and out as much as you need, looking at different areas. And we know it's been used now by over 15,000 individuals, so as well as educational professionals. Parents have also reported finding it very helpful, and health professionals as well. And evaluation of the resource has shown that it does improve teachers' knowledge about preterm birth, but also their confidence in how to support preterm born children in the classroom. And one final thing to mention that's a more recent development, the charity The Smallest Things have launched a Prem Aware Award for schools. And this is about, again, sort of improving awareness of the impacts of preterm birth on children's school. And this makes use of the resource that we've developed. And if you want to know any more about the Prem Aware Award, then the website there for the charity is given. So just to summarise what I've tried to talk about in this video. So we know that children born preterm are at risk for cognitive, attention, social and emotional problems, and that we know that these difficulties can impact on attainment at school, and especially mathematics. And I think because we know that cognitive skills training doesn't have the impact on education that we'd like, it's really educational professionals who will have a key role in supporting children, both by identifying specific areas of difficulties and providing appropriate support. But because the pattern of children's difficulties is very diverse, this really needs to be an individualised approach. And I'll repeat what I said earlier on, prematurity is just a risk factor, it's not a diagnosis. So just because a child's been born preterm, they won't necessarily have these difficulties. However, if a child is born preterm, and particularly very preterm, it's worth taking this into account and being aware of the areas that they might struggle in. And so just to finish, there's the website again for the resource, and thanks to all the colleagues, it's a big team that works on this, and the funding that we've received. Thanks.